So what we're doing now is we are having a look at this analysis question. Now, please don't do this. Don't watch this until you've actually done it. Now that I've said that, what you do is up to you. Application question. So we're going to read through this whole question. This is the way I'd tackle one of these questions, just so I know exactly what I need to do to be able to answer these things successfully. So if a ball is thrown upward, its height h in meters over time, t in seconds can be modelled by. So we've got that ht equals 3 plus, let's turn off characters. You people don't like them. H of t equals 3 plus 14t plus 3t squared. We want to determine the initial height of the ball. We want to determine the maximum height of the ball and how long it takes to reach it. How long is the ball in the air for? We want to sketch a graph of the height of the ball over an appropriate domain, showing all intercepts and turning points. And then we want to change it up a little bit. So the ball is thrown a second time from the same position. If it reaches the maximum height at the same time as the first throw, but the maximum height is 3 meters above the previous maximum, determine the new equation. And so we've got a little bit of interpretation what happens here. We'll see if we can go through all these in one video, otherwise we will break them up if we need to. Okay, so given that I'm using this equation and I'm using it a number of times here, at least 4, what I'm going to do is I'm going to define it. Instead of h of t, I'm going to define it as h of x because I'm sketching. And in CAS, we sketch over x, not t. Now we just got to remember that we go back, we're referring to time. So define h of x equals 3 plus 14t squared, 3 plus 14t, x plus, minus, x minus 3x squared. Let's just check that. So h of x, negative 3x squared, negative 3t squared, plus 14x, plus 14t, plus 3, plus 3. Good, it's all there. So we're going to determine the initial height of the ball. Initial height is when t equals what? 0. So I'm going to say h of 0 happens at 3. And that's all we'd have to write there. So it's 3, we'd say 3 meters because we're writing in units. So the initial height of the ball, this thing here, is 3 meters. What is the maximum height of the ball and how long does it take to reach it? A maximum height of the ball. Well, that's our turning point. It's another way of saying turning point, and we're after a maximum turning point. So lots of different ways we can do this. Let's complete the square. Square h of x for x. And it happens here, the maximum height is 58 over 3 meters is our maximum height, and that happens 7.7 over 3 seconds in. So max height is 58 over 3 meters at 7 over 3 seconds. Now, in the real world, we don't talk like that. So we may do 58 over 3. 58 divided by 3 will make it 0.0, so we get a decimal answer. So our maximum height is 19.33 meters, and that happens at 7 over 3, 7 over 3.0. That happens at 2.33 seconds. We may say something like that. So that's part B done. So that's what there. Now we want to find out how long the ball is in the air for. Now remember, the ball is being thrown. So let's draw this. Oh, no. Let's draw this. File, new. Don't save. So a ball is being thrown. So it starts off at a height of 3 meters. It goes up and then comes down. That's the way nature works. We want to find out how long, and this is time, remember, it's not distance, this is time. We want to find out how long it's in the air for. So it's thrown here, and it spends all of this time here in the air. So what are we looking for? We're looking for an x-intercept. So that's what we're going to do now. And then we're going to sketch it over that appropriate domain. That's our next question though. So how long is the ball in the air for? So what we want to do, we want to take this, we want to find an x-intercept. How do we find an x-intercept? What do? We solve. So solve h of x equals 0 for x. And it tells us we've got two x-intercepts. We've got one here at negative root 58 minus 7 over 3, and we've got one at positive root 58 plus 7 over 3. Well, it's going to be this one. Now, what we'll do is we'll sketch it, and then we'll come up with this thing here. So we're going to use this bit of information. So we're going to sketch this. So I'm going to say new, and we're going to sketch h of x. It's going to look like that. So here's our negative, and here's our positive. That's what we're interested in there. Now, we're after sketching this over an appropriate domain. Now, let's see. So we've done that with, so the ball is in the air for from 0 to this time. So what we'll do is we'll take this information and we'll put in a 0.0 to tell us that the ball is in the air for 4.87 seconds. So that's why we say that if we want an exact answer, it is root 58 plus 7 over 3 seconds or 4.87 seconds. Now, we want to sketch this over an appropriate domain. So what we're going to do is, so just by sketching it, where's my capstone? Here it is. So that's, hang on, let's go back to the questions. Found the height, found that, that's how long the ball's in the air for. Now we're going to sketch a graph over an appropriate domain. Show all intercepts and turning points. So what we're going to do is we'll go back to CAS. If we sketch this, this is the way it looks right now. So I'm going to change my window settings. I've got an x min of -5, that's fine. I've got a maximum of, say, we can go up to 10. We've got a y minimum of -2, and we'll go for a y maximum of 20. I think that's safe. Yeah, there we go. So that's what it kind of looks like. Now, we want to sketch this over an appropriate domain. Here, time is negative. No such thing as negative time, so we can't include this part. Also, this represents height. We're not showing what happens. Once it hits the ground, it's not going to keep going. It's not some sort of magical ball that goes through the ground. So over an appropriate domain means we are sketching it from here. We're sketching it to here. So we're going to sketch just this part. So what we do, we can just do it by hand and include this as our x-intercept, or we can actually define it. I'll show you how to define it so you've got that skill as well. So we're going to take this thing and we're going to say, we're going to redefine the function, define that, except we're going to say given 0 is less than or equal to x. So we're setting our lower boundary, which is then less than or equal to that value. No, didn't want that. What we want is this. I'm going to get rid of that decimal point so it's an exact answer. So that's done. Now we go to our graph, and like magic, it's only sketched for there. So now we've got to include intercepts. So we know that we've got a 0 here. So 4.87 and 0. If it asks for decimal answers, 2, 3, 4, whatever, we can use this. If it asks for exact answer, we use this. We want a y-intercept. Well, we know that it happens here at 3, so that's 0 and 3. And then we want a turning point, so menu, analyze graph, it's a maximum. Oops. 2.33 to 19.3, or we use our previous answer, which was 7 over 3 and 58 over 3 to write an exact form, depending on whatever you're asked to do. So that's that done. So that's sketching the ball over an appropriate domain. If we don't tell you what the domain is, we just say an appropriate domain. Okay, last thing. The ball is thrown from the same position, so it's going at the same height. If it reaches the maximum height at the same time as the first throw, but the maximum is 3 meters above the previous maximum, determine the new equation. So that tells us that we got our maximum. It still happens at 2.33 seconds, but it happens at 19.3. It's happening higher than that. So what we're going to do is I'm going to move this a little bit, and I'm going to change my window just so we can see what's happening. That's fine. Set our y minimum to -2 and our y maximum to say 25, just so we can see it. So from there, now what we're going to do is we're going to go to our thing, and we are going to complete the square if we can. Complete square h of x, comma x, and we've got, whoops, must respect to a second argument. Okay, anyhow, all right, we're going to use this thing. We know this is what we've got, so we've got that. Now, it's not. Now the time isn't changing. It's the same maximum height at the same time, so it's still 2 over 3. So this is not going to change. This part here is not going to change, but it is going to be 3 meters higher. So what we're going to do is we're going to write this, do this, and we're going to say plus 3 because we're shifting it up by 3. So that's what we've got now. So that's our thing. So I'm going to take that, copy, I'm going to go to CAD, I'm going to go to the graphing page, paste, and let's check. So I'm going to move this, and I'm going to say menu, analyze graph. We've got a maximum. Let's just check it. We're looking for this graph. 2.33, 22.3. That makes sense. But we've got a problem. This has gone up, and our x-intercept here is the same. That can't happen. This has got to stay the same. It's been thrown from the same position. Okay, so what do we do here? Well, we don't panic. We know that we are looking at this thing here. So we've got this equation. That's the one we're dealing with. That gives us that equation. But we also know that when x equals 0, now I haven't done this. Hang on, no, we won't do that. Let's use this thing. So that's what we've got there. I'm going to press enter. No. Can I complete the square on this? X. Alright. Now I know I've got negative 3. Actually, I'm just trying to work with this function here. So I've got negative 3 plus 58 over 3. So that's what I've got there. Alright, so now what I know is I'm going to take this thing here, and I have to multiply this, and I know that my my general form is a times x minus h all squared plus k. That's what I know that I've got. Now I know that my h value is negative 7 over 3, and that my k value is 58 over 3 plus 3, because it's gone up by 3 meters. So what I'm concerned about is this thing here. So I'm going to press enter and see what I get. I get a bit of a mess, but this is what I'm working with. Now I know that when x equals 0, y equals 3. So I'm going to say solve that, and instead of x I'm going to write 0, and I'm going to let it equal 3, and solve for a. It tells me a is negative 179 over 49. So I'm going to take this, and instead of a, I'm going to write negative 174 divided by 49, and I'm going to press enter, and that's what we've got there. So now what I'm going to do, I'm going to go over here, and I'm going to graph this, except instead of this, I am going to use this. Let's see if it works. Alright, so tab, let's go up. I'm going to turn this one off. So now we've got same x-intercept, so we've got the same y-intercepts, it's thrown from the same position, it's gone up, so 2.33, they're both the same, it's 3 meters high, and then it's still cutting through here at the same point. So that's what we do. So that's our new equation. So our new equation is this thing here, or we can have a look at it back here, and it is this. That's our new equation. So let's have a look at this again. Define our function, because we're using it over and over and over again. Initial height, we let x equal 0. That's what we've got there. We want to find the maximum height. We complete the square. That's our k. That's our h. Maximum height is 58 over 3, or 19.33, and that happens at 7 over 3, or 2.33. We want to find x-intercepts, so we let the function equal x, let the function equal 0, we solve for x, we get 2 values. We know this is a negative value, we can't have negative time, so we only accept this value here. That makes our domain. So we redefine the function, and we give it a domain between 0 and this value. We graph it, so it goes from here to here, and that's it, it won't go any further. We use CAS to find turning. We've already got x-intercept. We've got a y-intercept. We use CAS to find our turning point, or we use the information we've already got. From there, then we want to move it up by 3. So everything else is the same, but we're moving it up by 3. So we take we know we've got to have, so in turning point form, a x minus h plus k, we're moving it up by 3, so we've got our plus k plus 3. We've got our a value there. And then we substitute our x value, so x equals 0, y equals 3, which we know. We solve for a. And that gives us the value for a, and there's our new equation. And that's what we write down for that one. A lot of work, especially for that last question, but they're the steps that we take.